Okay, so today in Mr. Jeffrey's Algebra 2 with Stats, we're starting our vivid adventure into trigonometry. And also, for those in my class, we have a test next Tuesday. If you're not in my class and you do want to take the test, just email me and we can make that happen. So here's the deal. Now, I know some of y'all are like, oh, I had this before. Just because you had it before doesn't mean you learned it then. Okay. Now, all right. Right angle trig is the ratio of sides from the angle theta, pronounced theta. Okay. I actually did that out myself. I was kind of cackling when I did it. Now, when we're saying from theta, I don't know if anybody's ever taught y'all this, so I'm going to. We're saying from this perspective. Okay. Like if I'm in this corner back here, my opposite and my adjacent is a lot different than if I was in that corner over there. Okay. So you're looking from that angle. Okay. So now here's the definitions. We have sine, cosine, and tangent. Those are your three given ones. Then we have the inverses or reciprocals, not inverses, that's something totally different. We have cosecant, secant, and cotangent. Yes, if this seems weird, remember opium was the #1 over-the-counter medicine when all this was taking place. Okay, that's the definition. Okay, now let's actually try to use the definition. All right, so now here's what's different. The problems that were in the textbook that had you says find the 6 trig ratios, they actually did not include your hypotenuse right here. You already had to find that. I was like, why do we need to worry about that if we're just asking for the trig ratios? So we're going to start at make the main thing the main thing. Okay. So here's my angle. I'm looking right here. What side is opposite of this angle? 12. Okay. What side is adjacent? And hypotenuse is 13. Okay, so now our sine is opposite over hypotenuse. So this would be 12 over 13. Okay. Our cosine is our adjacent over our hypotenuse. So this would be 5 over 13. Okay. Our tangent is our opposite over our adjacent. Well, this would be 12 over 5. Now, I know I don't have the definitions on this slide, but if you happen to look up about maybe 1.5 to 2 inches from this problem on your handout, you would actually see those definitions. Now, cosecant, secant, and cotangent. It's the reciprocals of these things. I have them set up in like this for a reason. Reciprocal means we flip it. Okay. Was it one of the hidalgos that I flipped over? Yeah, that was a good day. Now, so if this is sine, our cosecant is 13 over 12. If this is our secant, or I'm sorry, our cosine, our secant is 13 over 5. If this is our tangent, our cotangent is 5 over 12. Okay, now, some of y'all are like, wow, that kind of made sense. It was set up to make sense. Remember, we're looking from theta. That's the corner we're in. Okay, it's all about the perspective. Okay, a lot of people they don't grasp that concept. That's if you don't know you're looking from this corner, you will never get anything else. Okay, all right. Are we good here? Does anybody need more time? Sorry, I forgot. If you're watching at home, you can just hit pause. We can't pause me. Okay, so in semi-black eye, the eye's getting a lot better. Hopefully stitches come out soon. Okay. All right. Now, this necessarily isn't in the textbook, like just a section of itself, and I didn't like that because here's the deal. Some of y'all, a lot of this stuff, Pythagorean theorem, you had in geometry. Some of y'all had geometry in the spring. Some of y'all had geometry like 2 years ago. It's a good refresher. Okay. So, using a squared plus b squared equals c squared to find the missing length. Now, I will tell you this. I have these set up so if you're missing the hypotenuse, this is the one that you do. If you're missing one of the legs, this is what you would do. That might be something good to put on that orange sheet to help you for the test next week. Okay, it's next Tuesday. All right, so I'm just going to plug stuff in. So I'm going to say 10 squared and then 24. Okay, you can actually type that in to the calculator as it looks. So, second, and then the x squared, get the square root. I'm going to say parenthesis 10 squared plus parenthesis 24 squared. Now, only reason I'm doing it with the parentheses is because it's set up just like it is on the paper. Okay, I hit enter. Bam, I get 26. So my hypotenuse for this one would be 26. Now I know all three sides. If I knew which angle I was looking for, I can find those trig ratios. Now, also, something with trig ratios that you need to remember. They're a fraction, right? Fractions can be reduced. FYI, BT dubs. TBH. All right. So we don't know what A is. A is this is usually our little side. Okay. This is our little side, our medium side, and our big side. Okay. Somebody said, oh, it's the baby bear, the mama bear, the daddy, whatever it takes for you to understand it. I don't care. Okay. So I know what C is. C is 10, so it would go here. B is 8. Now, plugging this in. I'm still going to do the parentheses because that's what's on my paper. Menos. Okay, so just like this, I would get 6. Okay. And we'll have a whole discussion about Pythagoras off camera because there's some really neat things y'all need to know about him. Okay. All right. And then we're missing the middle side. Okay. So 17 and this is 15. Okay. What? Oh, that's supposed to be subtraction. I did not catch that. Yeah, that's, we just can't have nothing. We can't have, can't have good lessons without a typo for Mr. Jeffries. It's supposed to be subtract. Okay. All right. And we would get 8. Okay. Now, I know some of y'all are like, well, that doesn't make sense because that's supposed to be the middle leg. Hey, here's the difference. Basically, this is what I have found in my many years of being alive. If you're missing the hypotenuse, you're going to use this one. If you're missing one of the legs, not like you got the hypotenuse, the side across from the right angle, you would use this. Okay. There's really no reason to have this other one because they're literally the same thing. You're just swapping out what goes here. Okay. Also, that would be something I might need to know. Okay. It's like the shortcut version. Hey, if I'm missing this, I use this. If I'm missing this, I use this. Okay. That would be one of my note to selves that I would do on my notes or on my orange sheet. Okay. Or a Freddy shirt. Have a student wearing a bright orange shirt today. It's pretty funny. All right. So now, if we look at the back, granted, y'all's copy of this did not show up super great on the back, but here's the deal. This is the main reason this is included. On Wednesday, when we start getting into the unit circle, okay, all this stuff will come back around. Okay, because we are literally dealing with 30, 60, 90s angles and 40 or triangles and 45, 45, 90 triangles. Okay, now this is up here as kind of like a little reminder that, you know, these things are important. Notice that it's in, well, on the screen it's in red. Y'all's is just there. That we're actually looking from this angle. That's why it's kind of different as you go through. And for this, also for this 30, 60, 90, remember the hypotenuse is 2 times this, and this is actually 1 times that. Okay, so now if we're looking at this, we're looking from theta. Theta happens to be right here. This is our 60 degrees. Okay, are we given our opposite side? No. We're given our adjacent, right? This is x, and our hip hop hypotenuse is 16. Okay, now if we're looking, which ratio can we use? Which ratio deals with adjacent and hypotenuse? Cosine, yes. Some people are like, I don't know. Well, flip your paper over and look back at the definition. It's cosine. Okay, so we can actually set this up to solve it. We can say the following. We can say that cosine of 60 degrees equals x over 16. Okay. Now, I'm showing y'all the hard way first. I'm going to show you the easy way. It's about 6 of one, half dozen of another. Okay. So if we were to multiply both sides by 16, all right, you know, we would have 16 cosine of 60 degrees equals x. Okay. Now, we can plug that in. Need to kind of make sure that our calculators is in degree mode. 16 cosine 60. All right. So if you're using a calculator, it would look like this. We would get 8. We just plug it straight in, get 8. Now, believe it or not, that's the long way. That's the long way. Some people will use that because they're like, I am so used to this. I like this. Now, there's a reason why I gave you those rules again about those 30, 60, 90 ones. Okay. If you look up here, this is always twice this side. So if we were given a hypotenuse of 16, we could actually say 16 divided by 2 is 8. We could have done the same thing. It just depends on how you want to do it. Some people are like, I don't like flipping back and forth between rules. That's fine. If you're one of those people that don't like to flip back and forth between rules, you just cannot shift gears that way, your clutch has gone bad, that's fine. Use what we have here. Okay? So, let's look at number 4. Here's our angle. We're given the opposite side and the hypotenuse. What ratio uses the opposite side and the hypotenuse? Sine. So we could say the sine, and that's pronounced sine, not sin. I know somebody's like, I always knew math was bad. It's a sin. All right, but this is x over 10. Okay. Well, we would multiply both sides by 10. Okay. So we would have 10 sine of 30 degrees. All right. So 10 sine 30. Yep. We get 5. Okay. Now, let's look at number 5. This is a 45. That means this is 45. These are congruent. That also means that these are also congruent. If you know it's a 45, 45, 90, those two sides have to be the same length. Do you really need to use a trig ratio to solve this? No. Do you actually have to do any type of calculation? No, because these are both the same. So x would actually be 10. That's using what you know. Okay. Using what you know. All right. Some of y'all are actually writing notes down today. That's actually great. Got more people writing down notes today. Maybe we'll have less repeated funny math. My favorite was like 1 minus 3 is 3. That was my favorite from Friday. That was so great. It was like 1 minus 3 is 3. That was some of the funny math I saw. It was awesome. Okay. Now, let's look right here. Okay. This is our angle. We have the adjacent side and the hypotenuse. What ratio is that? Cosine. Now, some of y'all are like, how did they get that so quick? Some people remembered it. If you don't remember it, you will have to look back at it. That's fine. It doesn't matter. We're not going to take you to the middle of school and throw stuff at you because you don't know these ratios off the top of your head right now. That's what the end of the semester is for. A what? A cooler dump? Oh, like at the end of the semester? Oh, yeah, that would be amazing. So, oops, 8 cosine 30. All right, now, what's kind of crazy, when I type this in the calculator, the way I have mine set up, it actually says 4 root 3. Now, if your calculator is not like mine, you would not get this answer. You would actually get 6.928. Okay? Now, what now? All right. Now, if you were to look at your rules of the 30, 60, 90, this is 8. This should be 4. This should be 4 root 3. Again, if you're using those rules. Yes. Huh? Uh, I'm going to be set for either way because I'm just going to say solve for x, and I'll be if I don't specify must be in this form, you know. All right. So this one, here's our angle. We have another adjacent, so we got another cosine. This is our adjacent, or this. All right, who wants to take bets that this is going to be 3? That's why I'm not agreeing to it, because I don't have $200. Okay, I don't even know if I might have a dollar bill in my wallet right now. No, I don't want to condone gambling. Okay, it's cheese and crackers. Some days it just doesn't pay to fall out of bed and come to school. Okay, so that would be 3. Now, if you didn't use the calculator, remember that this would have been 3. This would have been 3. What language is that? This, yeah. This would have been 3 root 3. Okay. Now, here's the deal. Um, all right. A lot of this stuff that I have y'all doing on your homework is setting some stuff up. If it actually says to reduce the fractions, you would need to reduce, because I actually made sure that if y'all wouldn't get wrong answers. Okay. I proofread the homework, but not the notes. Apparently I just copied, pasted, and roll tide. Okay. But now again, it's not very long, these homework assignments. Okay. I'm waiting for other people to finish copying this down. Hmm? Don't try to throw your calculator at the TV now. Yeah. All right. Now, there is homework in Schoology. It's in your best interest to get it done now, considering that we still have people that have zeros or such for your homework from last week. Okay. Now, it's due next Monday. Okay. This Friday, you will have a pre-practice test in Schoology to complete in class. Okay. Because I will not be here Friday. Okay. I have a doctor's appointment. A couple of times, not very much. Yep. Yes. Yeah. I just didn't have the heart to turn it in because I just didn't want you to cry. Yeah. Mm-hmm. All right. So that's it. Don't forget, hit like, hit subscribe, hit the bell. We have 106 subscribers now. So, remember, we get 200 subscribers. Get to paint my fingernails. Okay. Good stuff. Good things. Roll Tide.